Hey guys, here's your geometry video especially for Madison and Jack who had trouble connecting and being in here, but also for whoever needs any type of help from what we've learned, especially in 1.1. I don't think 9.2 and 9.3 will give you any trouble, but I do think it's possible that the other two might give you trouble. I'm sometimes now going to check and make sure we're good, the mic is going. So let's start. Chapter 9. 9.1 deals with similar right triangles. And so, really, this is a continuation of Chapter 8 that dealt only with similar triangles. Unfortunately, for all of you, this happened a month and a half ago, but we're going to review that. And we always said in Chapter 8, similar triangles have their angles congruent, just like congruent triangles, but instead of also having the sides congruent, they have the sides proportional, which means this side over the corresponding side will equal this side over this corresponding side and will equal this side over this corresponding side. That was the entire Chapter 8 problem. This is dealing with similar right triangles. This is a particular case. It deals with the triangle ACB, which is a right triangle, or ABC, however you want to call it. C is the right triangle. And it says the following thing. We are on page, just in case you don't know, 527. And this is the theorem 9.1 that you don't have to memorize, but you need to know what it says. It says that if you take an altitude from the right angle, so we're not talking about these two, just right angle, and you drop it down in the point D, this is your point D, and because it's an altitude forms 90-degree angles, 90 and 90, then you are creating literally three similar triangles because you have three triangles. You have the big triangle, then you have this little dotted triangle right here that I'm trying to dot, and then you have this the smallest of them all that I kind of drew. I'm going to put the dots a little bit bigger so you can see what I'm talking about. This triangle right there, right? And then this striped triangle, that's the smallest one. And this theorem says all three triangles are similar, which means number one, all of their corresponding angles are congruent, which means A is congruent to A and is congruent to C. If you look at this, A is the smallest side in the big triangle. A is the smallest angle in the big triangle. A is the smallest angle in the dotted triangle, which means C right here is the smallest angle in the striped triangle. So A will be congruent to A, which kind of makes sense. You are you and I am I, and so forth. And also congruent to the smallest side in that third triangle, which is smallest angle in that triangle, which is C. Also, all of the right triangles are congruent. Kind of makes sense, right? C is congruent to this D and is congruent to that D. They're 90 degrees. And then the other angle B in the big triangle will be congruent with the angle C in the dotted triangle. That's the biggest, the other angle, not the smallest, not 90 degrees, but next one. And then B is also congruent to itself in the striped triangle. Not only that, but all of the corresponding sides will be congruent. So if I use, I'm going to name them 1, 2, and 3. 1 is the big one, 2 is the median side one, 3 is the smallest triangle that we formed. This one is similar to this one, which means AC, which is the longest leg, over AD, which is that longer leg, will equal CB, which is the shortest leg, over DC, and will equal the two hypotenuses, AB over AC. So this is triangle 1 being similar to triangle 2, okay? Now, please remember, if I'm starting with the biggest triangle on the top, if I start with this one on the top, all of these sides will have to stay on the top. Never go AC on the top on my first fraction, and then AB gets on the bottom on my third. They all have to, wherever you started, that's your first triangle, that's where you go. Now, not only that, but triangle 2 is similar to triangle 3. That means AD, the longest leg, over CD, the longest leg in that one, will equal DC or CD in the shortest leg over DB, which is the shorter leg, and it will equal AC, which is the hypotenuse, over CB, which is the hypotenuse. And the third statement is that also 1 and 3 are similar to each other. Triangle 1 is similar to triangle 3, which means, again, longest leg, AC, over longest leg, CD, equal shortest leg, CB, over shortest leg, DB. And will equal the hypotenuse in the big triangle, AB, over the hypotenuse in the shortest one, which is CB. So this is what 9.1 is teaching you. That when you take a right triangle and from the right angle, you drop an altitude, you form 3 different triangles. They're all similar to each other. It looks super, super complicated. It's actually not. And so if we're going to flip the page on 529, and we're going to actually work 1 or 2 examples so you can have it as you watch your video, it's going to kind of make sense of how you're going to do your homework, okay? So example 1 says you have a roof line, and I should have not erased this, but I did. Here's your roof line. Again, you're dropping an altitude down, and here's what you know about the roof line. You know that this side of the roof is 5.3. The other one is 3.1, and the base of that roof is 6.3. You also know that this altitude is called h. There's 2 things that are asking you in example 1. Now, oh, and they also have names, and I forgot that this is z, x, w, and y. Number 1, and you're going to have this in the homework, is going to ask you to state the similar triangles. They're always going to be 3. Remember, this is 9.1. Once you drop that altitude, you have 3 triangles. The big triangle, the medium-sized triangle, and the small-sized triangle. Which means triangle, you can start however you want. X, Y, Z is similar. And since I started with the shortest leg in the big triangle, when I move to the median triangle, I have to start with the shortest leg. This is the shortest leg. Will be congruent to Y, W, Z. And will be congruent, I'm moving to this small triangle. I have to start with the shortest leg, X, W, Y. And here's another thing you always want to make sure. The middle letter should always represent a right angle. Y is the right angle. In this triangle, W is the right angle. In this triangle, W is the right. So now I have them set up the right way. We did part A, which said state the 3 similar triangles. Part B simply says find h. And I have kind of taught in the class that you're always going to follow 2 rules to know what you're going to use. Number 1, you're going to use a triangle that has the values needed, which means the most values that are defined. That they give you a number, they give you a letter, something is defined. And number 2, you're going to use the triangle that has the value needed, which means you're looking for the variable. In this case, we can do it however we want to do it. It doesn't matter. Number 1, I know I'm going to use the big triangle. How do I know this? Each side is defined. I have a 3.1, a 5.3, and a 6.3. So I'm going to use the triangle XYZ that is similar to, and I am free to pick either one of these 2 triangles. It doesn't matter. We can pick the medium-sized one, or we can pick the smaller-sized one. Because I used the medium one over here, I'm just going to use that one, YWZ. And here's why I know I need to use this. I need a triangle that has h in it. In this case, it's a happy case. Both little ones that are formed have h, so I can use it with whichever I want. So that means XY over YW will equal YZ over WZ will equal XZ over YZ. This is why it's so important to write these in the right order, because then you literally have the proportion done. 2 letters over 2 letters will equal second letters over second letters will equal first and third over first and third. It's just set up. Now let's go ahead and replace everything that we know, and then we decide what we're going to use. XY 3.1 over YWH equals YZ 5.3 over WZ. Do I know anything about WZ? Nope, I don't. I'm going to write WZ. And it will equal XZ, which is 6.3, over YZ. Oh, I did not write that one right correctly. What'd I do? Yeah, I did. 5.3, sorry. I got lost. I thought I don't have that value. YZ. Have you noticed how here you have a WZ unknown? We're just not going to use that middle one. Number, 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 variable. Remember the cross multiplying situation? This becomes 6.3 times age equals 3.1 times 5.3. I encourage you to use your calculator when you do this. I'm going to go ahead and just tell you that once you use your calculator, age comes up to be about 2.7. You're going to round to either 1 or 2 decimals. I'll take whatever you use. You can use 1 or 2. Don't go more than 2. We don't need more than 2. But this is kind of how this works. Okay? So, again, in order to find the missing, this is the whole purpose of the lesson, finding a missing value. All you have to do is first see which triangles you're going to use, the one that has the most values defined and numbers. Second, you're going to use one of the triangles that are formed that has the value needed or the variable that you're looking for. Let's go ahead and move on 529 or 530, and we're going to work 2 more examples on this one, and then we're going to move on to the next subchapter. They all work the exact same way. Example 2, part A, it gives you again, is the same situation. They don't even define them anymore. You have a right angle. It comes down with an age. And here's what you know. You have a 6, you have a 3, and you have, is it an age or an X? It's an X, sorry. And all they're asking of you is find the missing variable. In this case, it's X, right? So here's what I need to know. Remember, number 1, I should have erased this. Values needed. And number 2, values given. Values needed. This would be the variable. Okay, so I'm looking at this and I'm realizing that I do have one problem. And here's what happens. I'm missing any information on the big triangle. All I know the big triangle is that 6 and 3 together equals 9, but I do not have any of the legs. So clearly I cannot use the biggest triangle formed. But I can use the dotted one that I'm trying to use here because I have 2 values defined, and I can use the smaller stripe one because again I have 2 values defined, right? So let's see if I can do this. I'm going to start with the larger triangle over the smaller triangle. And what do I know? I know the longest leg, which is 6, over in the striped triangle, which one is the longest leg? X. Should equal the shorter leg in the dotted triangle, which is X, over the shortest leg in the striped triangle, which is 3. I'm going to go ahead and do the cross multiplication. X squared, X times X, X squared equals 6 times 3, which is 18. X equals square root of 18, and here you have two freedoms to work on. You can either tell me this is 3 square root of 2, if you're very familiar working with the square roots, and I'm just disappearing because I'm going to grab my phone. I don't have my calculator in here because I misplaced it. Or you can simply use a calculator, go square root of 18, you know, how we would do it normally. Can you see this? Yeah. And then this becomes 4.24. You can tell me it's 4.24. I will take both values. It doesn't matter which one of the 2 values you're going to use. I will take them. Okay? So you can either tell me 3 square root of 2 or 4.24. Let's look at part B, and then we're going to move on. I'm going to leave that there because we need it. Here's what they give us now. We're still on example 2, but this is part B. It looks like this time. Again, this is the right angle. We're dropping that altitude that we're talking about. And here's what I know. I know that this is 2, this is 5, and this is y this time. Again, remember, we need to work with, number 1, a triangle that has values given, and then a triangle that has a value needed. If I look at this, I cannot use this triangle at all, can I? The only thing that I know about this formed triangle here is that size is 5. I have 1 value and 1 value only. I can't use it, which means I'm going to have to use the big triangle y, because I can get the hypotenuse. 2 plus 5 is 7, right? So I know the hypotenuse in this one. If I look at this small triangle that I'm going to make it dotted for our sake, I have the hypotenuse is y. And then in this big triangle, I have the shortest leg, which is y. And in the dotted triangle, I have the shortest leg, which is 2. So I can work on this. Big hypotenuse, 7, over the hypotenuse of the dotted triangle, y, needs to equal the smallest leg of the big triangle, y, over the smallest leg of the dotted triangle, 2. This gives me again y squared equals square root of equals 14, or y equals, and you can give me 2 answers. You can be lazy and stay here, square root of 14, or you can go ahead and use your calculator and tell me that square root of 14 is, let me do this, 14, 3.74. I will be honest, I would prefer the decimal every single time just because it would be the same answer for everybody, but I'll take it. So really, the only difficult part that deals with 9.1 is for you to fully understand that we're looking at 3 triangles. We're always going to look for a missing side. And in order to do that, we're going to use one triangle that has the most values given. And then we're going to use another triangle that has the value needed or the variable. I hope this helps you. Your homework is assigned. And if we need to go back and reinforce this next class, we'll do it, okay? So this was 9.1. Okay, 9.2 dealt with the Pythagorean theorem. We have done this over. If you did math with me, you've done the Pythagorean theorem so many times, it's not funny. If you haven't, you probably did on your own in Algebra 1 or pre-algebra. And the Pythagorean theorem simply says this. I'm about to sneeze. Now, if you have a right triangle, which means that means one of the angles is a 90-degree angle, then the sum of the square of the legs will equal the hypotenuse squared. That's just simple as that. Now, if you get confused about anything, you need to know that most kids get confused about which one is the leg and which one is the hypotenuse. Simple thing. The legs are the sides that form the right triangle, which means A and B are my legs. What's left? C makes up the hypotenuse. So the legs are always the sides that form that 90 degree. Problems and examples. We're never going to look at the proofs that are in the book, but we're going to solve problems. If you move to page 536, example 1 says find the missing value or the hypotenuse 5, 12, and x. If you need help with this, you can go and say legs. What are my legs? Well, the legs, this is the right angle, form the right angle, which means it's 5 and 12, which means my hypotenuse is x. I can now set it up. 25 plus 144, I have skipped a step. It's 5 squared plus 12 squared, but I know this equals x squared. 169 equals x squared. X equals 13 once you use a calculator. Square root of 169 is 13. Which brings us to the topic Pythagorean triplets. And I wrote here a few of the examples of the triplets. There are certain numbers that simply work with the Pythagorean theorem, and they're all whole numbers. 3, 4, 5 is a Pythagorean triplet. 5, 12, and 13. We just worked one of them. It's a triplet. 7, 24, and 25. 8, 15, and 17. And actually, there's a lot more than just these. I'm not going to list them all. These are the most famous ones. I've seen them using the ACT a lot. So if you can remember those ones, it will help you a lot. And if you're going to have homework that's going to ask you to solve for something and ask you, is that a Pythagorean triplet? How do you know? In order for something to be a triplet, you have to have whole numbers. If you end up with square root of 10 or 3.7, not a triplet. The only way to be a triplet, whole numbers, okay? So in this case, we have a triplet, right? It's 5, 12, and 13. Let's see if we have a triplet here. Again, this is a right triangle. If you get confused, do this really fast. My legs form the right triangle. It's 7 and x, which leaves the hypotenuse 14. That's the value I didn't use, which means 49, which is 7 squared, plus x squared needs to equal 196, which is 14 squared. I'm just skipping one step because I know you know how to square and you can use a calculator. X squared is going to equal 147, which means x is, and again, use a calculator. You can even tell me that this is 7 squared of 3, or you can just go ahead and use a calculator and say square root of 147 is 12.12. Again, is this a triplet? 7, 12.12, and 14? No, because this is a decimal. So this would not be a triplet. This is a triplet because it has whole numbers. The only other type of problem like this you're going to do for your homework over and over again is just applying the Pythagorean theorem. The only way to go wrong is to confuse yourself about which one is the hypotenuse, okay? The only other type of problem that you're going to run into is one that's going to force you to use all of the knowledge that you've gotten in geometry so far, or you didn't really get it yet, which is example 3. That gives you a triangle that looks just like this. This is a right angle. It drops in altitude. We know this because, and mine is not drawn to scale. And it tells me that this is 7, that the other side, the other leg is 7, and the hypotenuse of the big triangle is 10. And they're asking you to solve what is the area of this triangle. Quick reminder, formula for the area of a triangle is half times base times height, or base times height divided by 2, however you want to write it down. Here's the problem that you're having. This is your height, and you don't know what that height is, right? But if you look at this triangle, the 2 legs are 7 and 7, which makes this triangle an isosceles triangle. Remember, not all 3 sides are equal. That would make an equilateral. 2 only sides are equal. That's an isosceles triangle, which means if you would dig deep in the back, you will remember that in an isosceles triangle, the altitude, it's also a median. It splits this in 2 half sides, which means if the whole thing is 10, then this becomes 5 and this becomes 5. And now I have a triangle that is a right triangle that I can solve for h. Again, my legs, they form this right triangle. That's what we're looking for because we're solving for L. So my legs are h and 5, right? These are the 2 legs. My hypotenuse, then it's 7. Let's go ahead and do h squared plus 25 equals 49. Again, a squared plus 5 squared, which is 25, equals 7 squared, which is 49. H squared is 49 minus 25, which is 24. H equals square root of 24. And again, please use a calculator. I should too, but they use it. They just leave it at square root of 24, I guess. In the book, square root of 24, which is 4.9. Now I can go ahead that I have my h, have my height. I can go ahead and find the area of the big triangle. Half times my base was 10, times my height, which is 4.9. Half of 10 is 5, times 4.9, which gives me 24.5, about, because we're rounding, right? About 24.5. That is the area. So this is the only type of problem that you had that was a little bit more difficult because it involved more knowledge. You had to remember the formula for the area of a triangle, super important for your ACT. You had to remember that this is an isosceles triangle, which means the altitude is also median, because you needed that information. Otherwise, you could have not found h. But once you got this part over here, then you have 3 different values. You can apply the Pythagorean theorem and solve for that h. And then you just replace it there. And this is about everything we have done in class for 9.2. Pythagorean theorem mostly will just have to do with squaring correctly, remembering which one is the hypotenuse, and giving me a decimal or the square root thing that we do there. Okay, the last part of what we did on Tuesday is 9.3, which is the converse of Pythagorean theorem. If you notice when I drew this, there's a marking missing here. I have not marked the right angle yet, right? And here's why. Because the Pythagorean theorem says if you have a right triangle with a marking, then this is true. The converse is also true, which means if you take a triangle and the shortest 2 sides squared and added together equal the longest side squared, then that makes this a right triangle. That's how you know it's a right triangle, okay? So you're going to use this just checking values. I didn't draw the triangles in example 1. By the way, we are on 543. On part A, you have a 7 and an 8 and a square root of 13. And it's going to ask you, is this the right triangle? Well, if you look at the drawing, square root of 14 looks like the hypotenuse, which means does 8 squared plus 7 squared equal square root of 113 all squared? Does it equal or not? We don't know that, but I do have a calculator and I can go 8 squared plus 7 squared gives me 113. Square root of 113 squared, this cancels that. It's 113. And if you get confused about that, just put in your calculator. 113 equals 113. Yes, this is a right triangle. Let's look at 1B. You have 4 square root of 95, 15, and 36. If you look at that drawing, 4 square root of 95 looks to be the hypotenuse. So that means that's 15 squared plus 36 squared. Does it equal 4 square root of 95 all squared? I don't know, but I'm going to check it. 15 squared plus 36 squared gives me 1,521. Should equal, let me put this in parentheses, 4 square root of 95 all squared, which is, no, not good. 4 square root of 95 come out 1,5. And of course, you have these answers in the book, but I want to show you that it does actually work. 1,520, does it equal? No, it does not. Not a right triangle. So that's all you're going to do over and over again and look and make sure. The only thing you need to make sure is that you're using the hypotenuse correctly. The drawing will show you how that works. Okay? The last part of this lesson, which is very short, was that the same kind of concept will teach us what kind of triangle we deal with. We know if this is equal to each other, then we get a right triangle. Right? But what if I'm going to use this type of triangle right here? And I was asking this in class over and over again. If you look at this and you classify it by its angles, what kind of triangle this is? This is an acute triangle. And you can use the same kind of situation to decide if a triangle is acute. And here's how you know that it happens. If a squared plus b squared is greater than c squared, if you look at the sides that are defined and the two smaller sides added together end up being greater than the longest side squared, that makes it an acute triangle. Also, we call this an obtuse triangle, right? And obtuse. Then in the exact same way, this is A, this is B, and this is C. Sorry, this is A, this is B, and this is C. C is always going to be the longest side. If A squared plus B squared is smaller than C squared, then you get a obtuse triangle. Now, what I want to remind you before we check some values here is, before you can even decide if a triangle is right or obtuse or acute, you have to decide if it's a triangle. Again, going back into 2 chapters ago, which said if I have A, B, and C as the side of the triangle, A, B, and C, any two sides that I add together have to be greater than the side that I didn't add. So A plus B always has to be greater than C, not equal, greater. B plus C always has to be greater than A, and A plus C always have to be greater than B. That's how we know we have a triangle. We did this in chapter 7, I think. So if you look at example 2, which is the last thing we've done in class, but then I'm going to work a guided practice with you so you see what I'm talking about. We're going to use these values, 38, 77, and 86, and decide what kind of triangle that is. Then we're going to use a, let me look in here. We're going to use, I'm going to use the book, 10.5, 36.5, 37.5, which is, again, example 2A and B. And then I'm going to also work down here, guided practice 4, which is 13, 5, and 7. And we're going to have to decide if these, what kind of triangles they are, basically. That's what we're looking for. Again, first thing you want to do is check that these are for real triangles. This plus this, roughly 115, greater than that one. Roughly 160, clearly greater than this one. Roughly 120, clearly greater than that one. I'm good to go. So now I need to decide 38 squared plus 77 squared is what compared to 86 squared. Let's go ahead and do the values. I have my calculator. I feel very good. 38 squared plus 77 squared is 7373. 86 squared is 7396. This is smaller, which means smaller. The addition is smaller than the one alone. This is an obtuse triangle. Let's look at the second one. First thing you want to do, make sure this exists. 47, clearly greater than 37.5. Roughly 70 something, clearly greater than 10. And roughly, 48, which is greater than 36. It works. This is the biggest side, which means 10.5 squared plus 36.5 squared is what compared to 37.5 squared? Can you still see that? Yes, you can. I'm going to do the math really fast. 10.5 squared plus 36.5 squared. 1442.5. Then I'm going to do 37.5 squared. 1406.25. This is greater than that one, right? Clearly greater, which makes this a acute triangle. Remember, if they would have been equal, we already know that. That's the Pythagorean theorem. It would have been a right triangle. Let's look at examples. Let's name this A, B, and we're a C. And you're going to look at this and you're going to say hypotenuse, two sides. Let's go at it. No, check if this is a triangle. 18 greater than 7. 12 not greater than 13. This is simply not a, you don't need to do any math to it. There's not a triangle because you added them up. 12 is not greater than 13. This triangle does not exist. So as you work homework on this one, this is the only homework that I assigned to you, please make sure the triangle exists before you decide it's right, acute, or obtuse. And this is it. This is all we did in class. Maddie and Jack, I hope this helps you. Let's try and communicate and see how we can get you back on Messenger. You're going to need a laptop. At least you can be both on the same laptop if we need to, but please get a bigger screen because you can tell. You need to see this. If you see this on a small phone screen, not going to work. Also, let me tell you this because you're not in class, how will this work? Homework. You do not need to send me a picture of your homework. All you have to do is the night before class, which would be Monday night your time, you would log into Google Classroom and say, Mija, page 527, I did not know how to do problem 13. You write it down as a comment. I did not know how to do this problem on this page. And that way I have time to review. And by the time we start class on Tuesday, we can start directly by working what you all didn't know how to work out. And then we'll move on to the new lesson. Test-wise, I need you to always take a picture of your test and upload it into Google Classroom. I'm going to go ahead and correct it, send it back to you. You have the option to give me corrections back within a week, and then we up the grade for half the credit of everything you did right. So test-wise, we're the same thing, except you have to upload a picture. Homework, don't send me a picture of the homework. I'm going to trust you. Please do your homework. This is your interest, not mine, so do your homework. But do upload anything you don't know how to do so I can go ahead and look it over and work with you in class. And yeah, that's all we did at class. I love you all, and I will see you next Tuesday. Bye.